All right, so let's correct this. No polygons yet. Number 1. So grab a pen or a marker. Just be honest. At this point in this course, an AC isn't gonna move the needle much up or down. So just be honest. Acing it or not doing so well is not going to affect you a whole lot because we've written so many. Looking at the chocolate bar from the top view, Brian states that it looks like a rectangle. State 2 properties of Brian's chocolate bar that make it a rectangle. You could say that it has 2 pairs of parallel sides. You could also say it has 2 pairs of equal sides or congruent sides. You could say that the diagonals are congruent. Diagonals bisect. All 4 angles are 90 degrees. Yes, all 4 angles are measure 90 degrees. Is there anything that I haven't mentioned that you feel like you need to be mentioned? If not, take 2. If you've got 2, you're good. Okay. Name the following triangles. So I don't know if the markings threw you off a little bit, but it's saying this side measures the same as that side. This angle has the same measure as that angle. So if you're going between side lengths and angles, it's okay to use different markings. And this one, right, this one is different than these 2 sides, but it's an isosceles triangle. Okay, isosceles in terms of side length, and in terms of angles, we're just gonna assume acute because we don't have anything else to go off of. So we just go by what it looks like. This one, out of the 3 angles, this one looks obtuse. Okay, so if you need on your study sheet to tell yourself acute, all angles will be less than 90, then there's right. That's gonna look exactly like this. And obtuse, it's bigger than 90, right? Like it opens further than just 90. So there you have it. This is an obtuse when it comes to angles, and scalene when it comes to side length. Yes?
I put obtuse for the first one. I thought the angle like were bigger than that.
This one looked bigger than 90 to you?
Yeah.
Sure. The province will be very clear on that. They'll put numbers in there most likely. So, fair enough. Sketch a rhombus and label all congruent parts. So what does that mean? Read carefully. It wants you to mention all the things that are equal to each other, right? So a rhombus, the first part should be that all 4 sides measure the same. That's one thing, that everything is the same that way. And then this angle has the same measure as that. I prefer you using this way to mark your angles. Okay, don't do the lines and across. I'm not sure. You could also argue that the diagonals, right, they're not the same in terms of their length, but this stretch will be the same as that stretch. This stretch will have the same measure as that stretch. I will say, if you did what I did at first, talking about the side lengths and the angles, you're good. You got 2 marks there.
What if you just have like the marks on like the sides and just look the angles?
Yeah, that's what I mean. That's already good enough for me. Because it has 2 marks. Okay. Anything? Keep going. A kite is a type of polygon. It is true, right? Polygon is like the umbrella that has all the shapes that we've studied under it. State two properties of this polygon, of the kite. You could say that diagonals meet at 90 degrees. That's one. It has two pairs of equal sides or congruent sides. It has one pair of equal angles, or angles that are equal. The short diagonal bisects. Yes, short diagonal. One thing that I want to mention, I'm giving you more than two, correct? Don't do that on the exam, because if you give more than what you need and whatever else you mention is wrong or contradicts, you're actually gonna lose marks. So don't show off, right? Just give me two, right? One on each line, and then move on, okay? Because if you do anything additionally and it contradicts your answer, you lose marks. And it's, yeah, and it's painful to not give you the marks, because I can clearly tell you know your stuff. It's just something happened, right? Okay, so hold on. Marks wise, we've got 2, 4, 6, 8. So this first page gets 8 marks attached to it. Back side, also from an old exam. Okay, copy paste. Martha's building a triangular ramp over a drainage pipe. She's considering the following. So what kind of, this one is a right because of that. This one, it's acute. We don't know what these are, but it's less than 90 for sure. So, and this one is definitely obtuse. This one is acute, sure, because if this is 80, right, you could have a 90 at 90 and 10, but that wouldn't make sense. The diagram wouldn't make sense. But anyways, they just give you the following designs. Choose the letter that best completes the statement. The type of triangular ramp that allows a wheelbarrow to be pushed smoothly over the pipe with the least amount of effort from either side is, would it be the acute, or would it be an equilateral, or would it be an obtuse, or would it be a right triangle? Which one of these three do you think would be best suited for this scenario? Which one do you think would take the least amount of work? Obtuse. The bigger this angle, right? Bigger, like if this had been 170, that would be even better, right? If this had been 170 degrees. So yeah, in this case, you want the obtuse to make it less work on either side. Justify why this type of triangle should be used for the ramp, making reference to the base angles. I will say this. A larger angle at the top, right? This top here, this is what I refer to with the top, will result in smaller angles at the base. And you use your own words as much as you want, but the bigger the top is, the smaller the angles on the base here. Okay, this would be base angle, this would also be base angle. So a bigger angle at the top will make these smaller, and a smaller angle makes it smoother to go across, to move over it. Okay, next, consider the following right trapezoid. So it gives you a name. You know a lot about right trapezoids. Calculate the value of the indicated angles or sides. This angle should be fairly straightforward. What do we know about these two here? They add up to 180, right? So you just go 180 minus 37. and that's 143 degrees. You get a mark for that one. Y, I will make that a 1 mark bonus today. Yeah. So what you need to do is you need to cut it here. Right? You're going to use, obviously this is the same as this over here, correct? So I'm going to use this triangle. This is Y. This is 2.5. This is a 90 here. Okay, the assumption is it's a right triangle because this stretch is the same as this, so it makes a 90 here. It's the height. And this is 37. So in a sense, you could use sine law here. Anybody notice that? So it's sine of 90 over 2.5 is equal to sine of 37 over y. So then you cross multiply here and you divide by sine of 90. Does anybody remember what sine of 90 is? It's 1. Yeah. And so this gives you 1. Use it. So this is a bit controversial. The sine law gives you 1.92. If you use Pythagorean theorem, you get 1.5. And that's, I take full blame, full responsibility for that, because when you allow more than one way to solve, you got to make sure this actually works out. And I didn't. So that's my so I accept 1.92. I would also accept 1.5. Okay, either one. If you use Pythagorean theorem, and how would you use Pythagorean theorem? I go 6 minus 4, and that gives me 2 here for this stretch. So it's 2.5 squared minus 2 squared, and then take the square root of that. You get 1.5. So this is a bonus today. It's a +1 if you got that right. So if you have one of these two answers, it's all or nothing. There's no halfers there. So what are we at in terms of marks? We've got 1, 2, 3. 3 marks, and then potentially bonus. So you could score 4 out of 3 on this page if you got it right. So what are we at? 8 and 3 gives you 11. So we're going to change that total that's on this page. Just cross it out like this and just make it out of 11. Your name and last name, and I'll take it from you. And then go to